We will see more about the Hadean. The absolute age of the first solid known to have formed in the solar system can be taken as the beginning of the Hadean time. So, the oldest material that we know is the calcium aluminum rich inclusions, and that occurs within the chondrite meteorites. If we pick up the chondrite meteorite and date the CaAl rich inclusions, we get the oldest known age from the solar system. The oldest known zircon, if we consider the zircon grain, then the oldest age is 4.4 billion year, which has been documented from the earth. In the previous slide, we said that the Archean gneiss, the zircon found within the Archean gneiss of age 4.02 billion year is the oldest known age from the earth. We have an update. The updated latest knowledge of the oldest zircon is 4.4 billion year. Where do we find it? We find it from the Jack Hill meta-sedimentary rocks from Australia. So, now this age can be taken as the boundary of the Hadean, and if we find still older zircon, then the Hadean's lower boundary will be pushed back. So, it depends on the future discovery as well. Where is this 4.4 billion year in the geological time scale? Here is the 4400 million year. Note this scale is in million year, which is same as 4.4 billion year. So, it is over here. Now, there is a classification of the Hadean as well, but it is not included in the geological time scale. If we look at the geological time scale, Hadean is kept as an informal unit, but it is not divided. If we look at the division from pre to the oldest zircon 4.4 or 4.404 billion year can be called as the chaotic era. That means, if I divide the Hadean informally, this is the span what has been called as the chaotic era. What happened there? Accretion of earth was forming, and then the giant moon forming impact event took place. If we believe that moon is produced due to impact on the earth, and there is younger part of Hadean, which is the Jack Hillsian or the Zirconian age, which is oldest zircon. What is the age? 4.404 billion year. 2 post means what? 4.4 from here to post, this portion has been called as the Jack Hillsian or Zirconian era. Now, one very important thing is that in the uranium lead dating process of zircon, it is sometimes problematic because the lead is mobile during post depositional metamorphism. If this is so, then the uranium lead that we are getting by using mass spectrometer for the zircon grain may not give the very accurate ages. So, in future actually one has to keep alert, noting the latest publications whether these ages are getting changed. Mineralization on the earth grew from pre-planetary asteroids and planetesimals. These planetesimals have been referred over here when we are talking about the accretion of the earth. Planetesimals were haphazardly moving and impacting, colliding, and the earth got accreted. This is one of the views, and at that time geoscientists say that there were around only 250 minerals present, and then the number grew from nearly 250 to nearly 1500 when the early earth with water came. When do you think the ocean has formed, or when do you think water was available on the earth? Was it the Archean? Was it the Proterozoic? I will provide only the summary information that in Archean time water was present. That is what the geologists have been speaking. And interestingly 250 to 100 1500 minerals, and then at present we have around 4800 mineral species. So, with progressive evolution of the earth, the number of minerals has increased drastically. From where the ocean water came? Summarily, it came from the volcanoes and from the comets. And note that the felsic crust formed by melting of the oceanic lithosphere. What is the meaning of the term felsic? It means light colored rocks, and here by saying felsic crust we mean to say rocks with quartz and feldspar minerals. The Hadean Archean boundary is now the oldest preserved crustal rock Acasta gneiss, and where it is? The Hadean Archean boundary, which is same as the boundary between Hadean and the Archean. So, it is over here. Note the time 4000 million year, which is same as 4 billion year. What is the age of the Acasta gneiss? Based on the zircon dating, I already referred that the age is 4.02 billion year, which is nearly same as 4 billion year. So, the Acasta gneiss is now taken as the boundary between the Hadean and the Archean. So, here within the Hadean two ages I can summarize 4400 million year or 4.4 billion year is the age of the Jack Hill metasedimentary rocks zircon, this has to be remembered, and 4000 or 4000 million year or 4 billion year is the time of the Acasta gneiss zircon that defines the Hadean Archean boundary, which is over here. So, now we are moving from Hadean into Archean. As you see in the geological time scale, above the Hadean lies the Archean. We are going to see it in some detail. So, here this is a zoomed portion of the Archean. It has been divided into Eoarchean, Paleoarchean, Mesoarchean and the Neoarchean. Let us look at some of them. The Paleoarchean, which is the crust, was mostly stagnant and mafic. No significant movement were happening. Plate tectonics in the way we understand today in the present day world was not active there. Rocks were mafic, that means dark colored, and it might be containing biotite and then amphibole, etc. The Paleoarchean ranges from 3600 to 3200 million year. Above the Paleoarchean, that means younger than the Paleoarchean, is the Mesoarchean rock, where there are evidences of mantle movement. Geologists have inferred overturn of the mantle material and the plume activity. What is a plume activity? The mantle material makes this kinds of bulging appearance and moves upward. This has been called as plume, and note that there is a debate amongst geoscientists whether pluming really happened in the geological past. The Mesoarchean ranges from 3200 million year up to 2800 million year, and then comes the Neoarchean, where the plume activity became very frequent and plate tectonics started. I have put a star, so we will see it in more detail. Neoarchean ranges from 2800 million year up to 2500 million year. That is the end of the Archean or the end of the Neoarchean, and we can also call this as the Archean Proterozoic boundary, because above Archean or younger than Archean lies the Proterozoic rocks. The lower mantle basalt eclogitized, that means it became eclogite around 3 billion year by coming in contact with the sea water. Where is 3 billion year within it? That means essentially we are talking about the Mesoarchean time. This is the time, you see this is 3200 and this is 2800. In between will lie 3 billion year or 3000 million year. So, in the Mesoarchean time this has happened. Eclogite was formed. Eclogite is presently understood as a metamorphic rock of high density more than 3 gram per centimeter cube. So, therefore, it is a heavy and it is a mantle material, one of the significant rocks in the mantle. However, in some parts of the earth surface eclogite is available for study. Let us look at the Archean Proterozoic boundary. Where is that? Here it is the Archean Proterozoic boundary. What is the timing? Students have to remember it is around 2500 million year. What happened there? Genesis of banded iron formation was maximized. Banded iron formation is defined by alternate bands of iron and other minerals. For example, the banded hematite quartzite and the banded magnetite quartzite are the examples. They started forming in this Archean Proterozoic boundary, and you have to remember. But their production got slowed down after the Great Oxygenation Event GOE. But the timing of the Great Oxygenation Event, that is the timing when in the atmosphere there was a great concentration of oxygen compared to what was there already. Note that before Great Oxygenation Event also some oxygen might be there in the atmosphere, but after this event happened, then the situation changed drastically and earth became favorable to host life. That is what is said. Once life emerged, and it emerged in the sea water in form of algae, and photosynthesis started in a preliminary form, then the number of minerals rose to more than 4000. Previously I said that the number of minerals from the asteroids what we get is only 250 or so. The number got increased to 1500 when on the early earth with water, and then when this basic photosynthesis started, the number of minerals increased and oxides and hydroxides formed. So, the way the abiotic earth has changed with time has significantly controlled the evolution of life as well. Now, we are going to see in the Paleoarchean, in the Mesoarchean and in the Neoarchean how the plate tectonics has changed. This is a cartoon of the situation of the Archean tectonics as we understand, but these ideas also keep on revising, changing. At an age more than 3200 million year, which means we are talking about this age more than 3200 million year. What happened? There were small wavelength mantle convection going on. TTG was produced. What is that? Tonalite transamite granitoid. This is an assemblage of rock typical of Archean age. TTG group of rock is also present in Indian plate and in India. Then if we move to younger Archean rocks 3200 to 2500 million year, that means 3200 to 2500, we are talking about this range which includes the Mesoarchean and the Neoarchean. Cratonization has happened. What does this mean? This means craton has formed. Craton has another synonym called shield. These are the tectonically stable parts on the earth's crust. They got formed. In India, we have many cratons such as the Shingbum craton. And in age younger than 2500 million year, where is that? That means I said the Archean Proterozoic boundary is 2500 million years. So, younger than that age, what has happened? Large wavelength mantle convection started. So, we can see a difference between the mantle convection style. Archean Proterozoic boundary onward, large wavelength mantle convection started, whereas in the past it was small wavelength mantle convection. Cratons got stabilized and collisional orogens and supercontinents got produced. Rock types that came into existence are calc-alkaline and andesitic crust. Regarding supercontinent, we will see very soon a few things. Now, if we look at how the plates have behaved with time, more than 3200 million year back, we can call the tectonics as basically pre-plate tectonics, significantly different from the modern day plate tectonics. What happened there? TTG was produced, vertical delaminating lithosphere has been envisaged, and this kind of subduction has also been thought about. The plume was moving out and the keel geometry was established, and at the top there was the mafic crust. Now, in the transition phase 3200 to 2500 million year, which is including Mesoarchean and Neo-Archean, there deflected delaminating lithosphere has been visualized, where you see the lithosphere that goes inside the asthenosphere is curved and much different from what has happened from the great oxygenation event and younger. That means from Archean Proterozoic boundary till what is acting today, that the oceanic lithosphere steadily goes down as a slab, although there are different views about this subduction and how it happens, the mechanism. But overall, this is what we agree: magmatic arc is established, stabilized continental lithosphere has developed. So, you can see from earlier what we said as mafic crust, now we are thinking in terms of lithosphere. This is a time when felsic crust has been produced. So, through these diagrams I have said how summarily tectonics has changed with time. Note that these time divisions more than 3200 million year, 3200 to 2500 and less than 2500 are not the divisions of Paleoarchean, Mesoarchean and Neo-Archean. Rather, we have considered Paleoarchean as more than 3200 million year, and then Meso and Neo-Archean together as 3200 to 2500 million year, and the younger than 2500 million year tectonic events have been taken into consideration. Now, we are going to see Precambrian rocks and comment about it. The Precambrian succession is given over here, Archean and the Proterozoic, above which comes the Cambrian. So, before Cambrian is known as the Precambrian rocks. Now, we are not talking about only the Archean rocks, rather we are talking the Archean rocks and the Proterozoic rocks together. They constitute less than 20% of the total area of the rocks exposed on the earth's surface. So, we have limited understanding of the Precambrian history. Most information about the Precambrian rock is coming from the cratons, and the synonym is the shield. Numerous felsic bodies of rocks, protocontinents, coalesce to form microcontinents, and these microcontinents again join to form the continents. The total amount of continental crust grew rapidly. The greenstone belts developed in the Archean. This is important, this term you have to remember. At what time the greenstone belts developed on the earth's surface? The answer is it is in Archean. So, when we are talking about Precambrian rocks, specifically we talked over here about the Archean rocks, which is over there. This is a time when the greenstone belts produced. In India we have greenstone belts. The green color comes from the green colored mineral, which is chlorite. What is this greenstone belt rock? Mostly mafic and ultramafic volcanic rocks, and then there are pillow structures, which is a primary igneous structure, and it indicates extrusion inside the sea. So, sea water was in contact with the greenstone when greenstone was forming, which means that in Archean water was present. In the Proterozoic, we have evidence of deep water sedimentary rocks forming such as greywacke, mudstones and BIF. Note that in the Archean, along the margin of the so called continents, there was sedimentation at the shallow sea, whereas in the deep sea or in the deep water, in the Proterozoic rocks, we have the greywacke, which is clay enriched sandstone, mudstones and the banded iron formation. Stromatolite fossils of this age, photosynthesis has started, and in the Archean sea floor around 3.5 billion years ago. Where is 3.5 over here? This is 4000 and this is 3600. So, 3.5 or 3500 will be somewhere here, that is the Eoarchean. So, in the Eoarchean, stromatolite fossils came into existence and photosynthesis started. So, whatever information I am giving, I am requesting the students to use an A3 paper or even an A0 paper, and on that write down everything, the important points to recollect. There was no evidence of fossil representing eukaryotic cells. What is eukaryotic cell? They are the cells containing chromosomes and nuclei. We do not have such evidences in the Precambrian rocks. The largest sink for oxygen in the Earth's early crust were reservoirs of reduced iron and sulfur, and not enough oxygen was available to oxidize all the reduced iron and sulfur. Pyrite got deposited on this time, indicating a reducing environment. Deposition of pyrite indicates a reducing environment. We sometimes have chalcopyrite and arsenopyrite. Arsenopyrite has a formula FeAsS2, where arsenic can enter the chemical structure of pyrite subsequently. Late in the Archean time, when the Archean was ending, cyanobacteria and other bacteria started releasing oxygen, and the great oxygenation event happened. That means, these activities got peaked in the Archean Proterozoic boundary 2500 million year back. Now, we are going to see little bit about the Proterozoic. First, we covered discussion on the Archean, then we made some comments about the Precambrian. Now, we are going to see specifically about the Proterozoic. Now, in this Proterozoic has been divided into three eras: Paleoproterozoic, Mesoproterozoic and the Neoproterozoic. Let us start with Paleoproterozoic. It is the Earth's first, it is a time when Earth's first supercontinent Columbia or Nuna developed. Sedimentation happened in the shallow seas in the Proterozoic, and it is in contrast to the deep water deposition in the Archean. During the Proterozoic time, more sedimentary rocks remained unmetamorphosed. So, we have the Proterozoic basins, and in India particularly we call them as the Purana basins. The Bhima basin, the Kaladgi basin, the Kadapa basin are the examples of the Purana basins where the Proterozoic sediments are found, and they are mostly unmetamorphosed. Within the Neoproterozoic era comes the Ediacaran period. It is important. This is the Neoproterozoic era, and if you look from the bottom towards top, the topmost period is the Ediacaran period. It is the time that we get the Ediacara fossils. And amongst all the periods in the geological time scale, it is the longest. My question to the students: look at the geological time scale and find out it persisted for how many million years. And I am asking you also to look at the geological time scale and find out the shortest period. So, the possible questions can be which one is the longest period and which one is the shortest period. If you look at eon wise, which eon represents longest time span, find out the answer. There has been report of widespread glaciation in the Proterozoic. This is the first report of glaciation in the earth in terms of time. This is the first time happened on the earth. Whenever glaciation has taken place on the earth, the sea level will fall down. Once the sea level falls down, regression, the ecology in the shore area gets changed, and this gives a good chance of evolution of life. New species might be produced, or some species might got reduced in number or get stressed. Cyanobacteria flourished in ocean and eukaryotes joined them. These are the important events. Animals in the true sense probably originated during Neoproterozoic. Multicellular green and red algae were abundant in the Neoproterozoic time. Over here we are talking in the Neoproterozoic time. The Ediacaran period is within the Neoproterozoic era. This you can see, this is the Neoproterozoic era, and within that the youngest one is the Ediacaran period. And we said at the Archean Proterozoic boundary 2500, great oxygenation event BIF formation picked up, wherein peak, and it became rarely developing after 1.85 billion year. This is 1800 million year, this is 1600, and this is 2050. So, somewhere in between within the Paleoproterozoic, the BIF formation got reduced. So, the BIF mostly formed on the earth at the Archean Proterozoic boundary, and it continued almost till, I can write, 1.85 billion year, which is in the Paleoproterozoic. But note that this does not mean that the iron rich sedimentation stopped. There are pelagic, hemipelagic sedimentation that had happened later also. Later means younger than this Paleoproterozoic also. Note that when we say Paleoproterozoic, it is a time range, and here is the specific time geologists have been saying. This 1.85 lies within the Paleoproterozoic. The first supercontinent formed by joining different microcontinents was Columbia or Nuna, and it remained intact for almost 400 million years, very long time, but then it started breaking possibly in the Archean Proterozoic boundary, which is over here. 2500 million year is same as 2.5 billion year.